Hello and welcome back to Geometry. Today we will cover Section 1.6, Two-Dimensional Figures, and complete the guided notes. First up, what we will learn in this section, let's skim the lesson, write two things you already know about two-dimensional figures. I'm going to have to pretend here, because yes, as the teacher, I will already know most of this, but let's look at what we've got here. Identifying polygons, polygon vertex. Here's a diagram. That's that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 sides. Hey, that's a hexagon. Maybe we could name some polygons if we already know. Polygon versus not polygon. Okay, we'll make that distinction. Concave versus convex. Maybe you don't already know that. N-gon, equilateral. Oh, here's the full list of names. Maybe you already know some of these. We could definitely write that down as something we already know about two-dimensional figures. I know that 3 sides is a triangle, 4 sides, quadrilateral, 5 sides, pentagon, 6 sides, hexagon. You probably know 8 sides is octagon. That might be it. If you know any of the others, feel free to add those in. Be honest. This is just to activate your brain and connect back to knowledge you're already familiar with. Let's see what else we can find in here. Naming and classifying, absolutely. Ooh, perimeter, circumference, and area. Hey, I know the areas of some things. Let's not spoil it. I know the area of a rectangle is length times width. And I remember area of a triangle is 1/2 times base times height. Sure. Maybe you don't remember what's base and height, but we'll find out as we read the section. Okay, then, so preparing to fill out the vocabulary, let's go ahead and read from the very beginning. We are going to start with identifying polygons. Most of the closed figures shown in the mosaic are polygons. What? Oh, the mosaic. You can barely tell on this blurry image here, but yes, this is a mosaic made of teeny tiny pieces of tile. The term polygon is derived from a Greek word meaning many angles. That's right there. Many, gons is angles. So a polygon, here's the definition, a closed figure formed by a finite number of coplanar segments called sides, such that the sides that have a common endpoint are non-collinear, and each side intersects exactly 2 other sides, but only at their endpoints. That's a lot. Let's try to break this down a little bit. First up, closed figure. Figure is just a drawing. Closed means you've gone all the way around and come back and joined to yourself. So if you just drew this, you're not done yet. Of course, it also said it's a finite number of segments, so it's got to be all straight pieces, no zigzags. And those should actually connect to each other. And this bit about the sides have a common endpoint, and they're non-collinear, so you cannot say this is a side, and say, oh no, those are 2 different sides of the polygon, because, well, no, that's just one really long side. Okay, that's what we're clearing up by that. And each side intersects exactly 2 other sides. So notice that this one here connects to 2 others. We're not going to start branching off into other pieces and call that all one polygon. All right, clear that up. Continuing on, the vertex of each angle is a vertex of the polygon. So we're reusing that term vertex from the previous section. A polygon is named by the letters of its vertices, written in order of consecutive vertices. So here is our example. We have a polygon here, side, segment GH. Point J is a vertex of angle HJK, but it's also a vertex of the whole polygon. The polygon could be named GHJKLM. You can start anywhere. We could call this polygon JKLMGH, and that would be fine. You could go backwards. You could call this polygon MLKJHG. That's fine. What you cannot do is skip around and say GHMHJL. That's not acceptable. The table below, oh, wait. Let's fill in our vocabulary before we keep reading. Closed figure formed by sides. Let's see down here. It's a bit of a mouthful, but for the sake of absolute clarity, what is and is not a polygon, we need all of those words here. Closed figure formed by coplanar segments where two segments intersect at a common non-collinear endpoint is a polygon. And the vertex of such a polygon would be vertex of the angle, or that's where the sides meet, where two sides of a polygon intersect. Oh, it's right here, very beginning. Okay, back to here. The table below shows some additional examples of polygons, some examples of figures that are not polygons. So here, these are all valid. These are not valid. Notice this looks like two triangles connected to each other. This one is an open shape. You're letting all the sheep out. This has curved pieces. So does this. This is all curved. And this just has an extra stick pointing out the end. Get rid of that. Only the parts that make the enclosure. What else? Polygons can be concave or convex. Suppose the line containing each side is drawn, the whole line. So notice they're extending the sides here with the little arrows. If any of the lines contain any points in the interior of the polygon, then it is concave. Otherwise, it is convex. So notice here, none of the inside is on those lines, whereas if you draw this shape, a deltoid here, extending this line would run through the middle of the polygon. So we've got some interior intersections going on there. So that makes it concave. Visually, it looks like something has caved in. If you take a convex polygon made out of cardboard or something and push really hard on the one side, you could collapse it in on itself and make it cave in and make it concave. So a polygon with no side passing through the interior, convex, and polygon with some sides passing through the interior, concave. Let's go on. In general, a polygon is classified by its number of sides. The table lists some common names for various categories of polygon. A polygon with n sides is an n-gon. For example, a polygon with 15 sides is a 15-gon. And this applies to all the numbers, not just the bigger ones. You could call a 5-sided polygon a 5-gon. We have taken the Greek word for 5, penta, and used it here. So pentagon does literally mean 5-gon. That's the Greek prefixes over here. An equilateral polygon is a polygon in which all sides are congruent. An equiangular polygon is a polygon in which all angles are congruent. They both start with the word equals, and this one has lateral like a line, like the side, and this one has angular like the angles. So let's add, here we go, polygon with n number of sides is the n-gon. And polygon where all angles are congruent is equiangular. Polygon where all sides are congruent, equilateral. A convex polygon that is both equilateral and equiangular is called a regular polygon. An irregular polygon is a polygon that is not regular. So this and only this shape is the regular pentagon. Any other five-siders are irregular pentagons. The irregular ones are probably the ones you might have had as a small child if you had blocks, say, growing up. They were almost certainly the regular shapes. Let's see if we can find that. Equilateral and equiangular. Convex polygon, equilateral and equiangular, regular. Please note polygons and circles are simple closed curves. Curve is the mathematically broader term for any line. Anything you're drawing with your pencil is a curve. If you connect back to yourself, it's closed and without crossing itself. So this one is not closed and this one is not simple because it crosses itself. And we'll do the examples properly in part 2, as per usual. Next up, finding perimeter, circumference, and area. The perimeter of a polygon is the sum of the lengths of the sides of the polygon. Some shapes have special formulas for perimeter, but all are derived from the basic definition. So you could always find perimeter by just adding the sides. Specific shapes sometimes have shortcuts. You will derive these formulas in Chapter 11. The circumference of a circle is the distance around the circle. You may be familiar with circumnavigating the globe. Same idea there. Circum is circular. And then the area of a figure is the number of square units needed to cover a surface. Review the formulas for the perimeter and area of 3 common polygons and circles given below. So we'll take a look at that after catching up on vocabulary here. We have perimeter of a circle, that's the circumference. Sum of the lengths of a polygon's sides is the perimeter. Number of square units needed to cover a surface is the area. So before we go on to the main idea, let's look at that chart there. We have triangle here, perimeter at all 3 sides, area 1/2 base times height. I think that's what I said before. Is that what I did? Yeah, b times h. So b for the base, h for the height. Good old square. Squares have 4 of the same sides, so the perimeter could be reduced to 4 times that side length. The area is side squared. Rectangle, any length times width. You'll have 2 of each, so 2 L's plus 2 W's for the perimeter, and L times W for the area. And the circle gets the special one. Circumference is 2 pi r, or pi times diameter. Area is pi r squared. Note that that symbol is the Greek letter pi. If no calculator is available, 3.14 is good enough for this class, but it is an irrational number. The decimals go on forever and ever with no repeats. So we'll do a couple examples of calculating those in part 2. And then, yeah, that's another note on distance and irrational numbers. We've addressed that before. Note that you can use the distance formula to find the perimeter of a polygon graphed on a coordinate plane. It's going to be very difficult to get all the sides to line up in perfectly vertical or horizontal directions, so you're going to have to use the distance formula to find some of those. But that is the end of the section. So we'll have 4 examples to do in part 2 for now. Let's return to the next page of notes, talk about the main idea. Identifying polygons. Fill in the organizer about polygons. We have 4 sections here. What is a polygon? What is not a polygon? All right, I'm going to try best from memory what made a polygon. It was a closed figure made of segments. Oh, I'm sorry, it was a simple closed figure. Remember that call out on the side there, no crossing over themselves. Made of segments, okay, whose sides intersect at their endpoints, called a vertex. All right, some examples of polygons. We can draw some here. Our good friend the square, a triangle, and we could go really, let's go for a really crazy one in here. We'll just start adding pieces. Remember, it doesn't have to be convex. We can do something like that. That's a polygon too. What is not a polygon? Some non-examples, if you recall, things that didn't work. Anything that had some non-straight sides. Okay, so that was not a polygon. Anything that didn't enclose itself, that was not a polygon. Anything that crossed over itself, it's not a polygon. Poor old bow tie. Okay. So what is not a polygon? It would be a figure that crosses itself or is not closed or has curved sides. Of course, we could also go really crazy. What is not a polygon? Any 3D shapes. Could throw that in there, right? It's a non-example. You're just going to have to trust me on this. We'll draw a quick pyramid here. Any 3D shapes are not polygons. What else? Perimeter, circumference, and area. Summarize the formulas for perimeter, circumference, and area of the figures by completing the chart. Okay, so we are pretty much going to be recreating this table from here. So let's take it line by line. The areas of the triangle. Area of triangle equals 1/2 base times height. Height is not on the side. If this is the base, then its height here is perpendicular. The square has sides S. Area is S squared. Rectangle has length and width. Area was length times width. And the circle has only one necessary measurement. That's radius. Area was pi times r squared. The next line, perimeter and circumference. Well, only the circle has a circumference, and its circumference is in place of its perimeter. So the perimeter of the triangle, A plus B plus C. I guess I got to label these other sides, A and C there. The square has all four of the same sides, S. Hold on. Not A. Perimeter starts with a P. Okay, and then rectangle is 2 L's plus 2 W's. Just to be clear, those are also L and W. And the circumference for the circle is 2 pi times radius. There we go. And that's it. So this concludes the guided notes for section 1-6. Come back for part 2 to complete the example problems from the section. So long, farewell, enjoy the rest of your day.